Okay, here's 2011 question 5. Taking a look at this, this is a differential equations problem, usually associated with slope fields, but in this case there is no slope fields. But here we go. Just right off the bat, most people tend to flip out because there's no more y's and x's. So if it helps, usually what I do here is we normally have things written out as x comma y and dy over dx. Notice how it's dw over dt. So really your t value is really just your x, and your w is really just your y. Okay, so I personally like to just do that so that I don't get confused afterwards, okay? Part A, use the line tangent to the graph of f at t equals 0 to approximate. So, key word here, line tangent. You need the equation of a tangent line. To make it, we need two things. We need a point and a slope. So in this case, the point would be at t equals 0. Now, what we're missing is the amount of w, in this case, the amount of waste. So do I know how much waste I have at t equals 0? They actually stated in the very first sentence here. So I know that my point is going to be 0, 1400. All I'm missing is the slope. So remember that slope means derivative, and they actually give it to you. dw over dt, that is the slope, okay? And we want to find out what the slope is at t equals 0. So big mistake that people make, they try to plug in 0 for w, okay? Remember, 0 represents time. We have to plug in the amount of waste at that time. So we're actually plugging in 1400. You could definitely play the equals equal card, but just to keep things a little bit cleaner, this comes out to about 44. Okay? So now that you guys have a point and a slope, I'll squeeze it in right here. That'll be y, so in this case, w minus 1400 equals the slope times x, but instead of x, I'm using t minus 0. That's enough to leave it as equal. If you guys noticed, they went a little bit further, and that's fine. But the thing is, now they ask you to approximate. So with approximations, you actually do have to isolate w in this case. So here we go. W will equal 44 t minus the 0, but I won't write that, plus the 1400 once we bring it over. We want to approximate the amount of waste at time t equals 1/4. Again, this is enough to leave it as is. Equal is equal. Again, do the bare minimum because 1, you don't get any extra points, and 2, you could lose points, but 3, it could save you a lot of time. So just keep that in mind. In the scoring guidelines, they wrote tons. It's really not necessary, okay? And I wouldn't even write approximately, okay? I would just do W. I would probably just do 44 times 1/4 plus 1400, and then just leave it there, all right? Part B, find the second derivative in terms of W, okay? So this one does pop up enough for you to want to remember, okay? So here's what I'm going to do. I'm going to write dw over dt equals 1/25 w minus 300. What I'm going to do first is I am going to distribute this. So that'll be 1/25 w minus 300 over 25. Just to make the next part a little bit easier to understand. So there's a long version and a short version. I'm just going to give you guys a short version here. To get the second derivative, just keep in mind what you're taking the derivative of, okay? So 1/25 w here, the derivative of that is just 1/25, but with respect to w. That's really the only new piece here. I'm going to right away divide this by dt. The derivative of 300 over 25 is just a constant, so it's 0. So here, what you have to do is, we know what dw over dt is, so you have to go one step further. You re-plug in what dw over dt is. So in this case, it's 1 over 25 w minus 300. Equal is equal. You could definitely just leave it right there. I think they went a little bit further. They cleaned it up a little bit, but really it's not necessary, okay? Okay, so they ask you to find the second derivative, and then they ask you to determine whether this is an under and over estimate at t equals 1/4, okay? So basically what you have to do is, in order to know if something is an over or an under estimate, some background knowledge. If you guys are looking at a tangent line will always be underneath the curve if the curve is concave up. So in this case, the approximation would be an underestimate. Now, the function is concave down. Notice how your tangent lines are going to appear above it, implying that your approximations are going to be over. So the only factor that we have here is we have to know what the concavity is. And if we know what the concavity is, we can determine whether the estimate is under or over. So what we do is, if we're looking at t equals 0, okay? At t equals 0, I know the waist is at 1400. At t equals 1/4, I know the waist comes out to 1411. This was from part A, by the way. But just take a look at the W values. It's definitely something in the 1400 range. If you guys plug 1400 into here, or even 1411, you know that inside the parentheses, that's going to come out positive. And if you multiply with more positives, the whole thing is just going to come out positive. So we now know that the second derivative has to come out positive, which implies that W is concave up, which implies that the tangent lines are an underestimate. That's basically it. Okay? Last one here, which is where the majority of your points are going, it's finding a particular solution. So remember, going back to the variable switch, instead of y, it's just w. Instead of x, it's just t. Okay? So here we go. We have dw over dt equals 1 over 25 times w minus 300. So since w is y, we want to keep w on the left. So we would have to take this whole thing and bring it to the left. And the way we do that is we would just divide by w minus 300 on both sides. Okay? 1 over 25, we'll just leave it there, okay? Now the dt, we would have to multiply on both sides. So then you would get this, okay? You have to know how to separate your variables. If you can't separate your variables, you pretty much forfeit 5 to 6 points, which is a lot. So with practice, you guys could actually get a good chunk of your points here. Now, going further, when you integrate the right-hand side, 1 over 25, which is a constant, it's pretty much just 1 over 25t. Okay? Now here, 1 over something linear, you guys should know, is a natural log. That does pop up occasionally, okay? That should give you an additional 1 or 2 more points. In this case, it's just 1. So you get 1 point for separating, another point for integrating, and then you actually get a point for putting a plus c. Don't forget that plus c, okay? The moment you guys have this, remember, we separated, we integrated, now we have to isolate, but we have to find our C first, okay? So what we do is we plug in our condition. At t equals 0, the waist is 1400. So basically, if you follow me here, 1400 minus 300 is 1100. So we have the natural log of 1100 equals just C, because the 1 over 25 is being multiplied by 0. The moment you guys know what C is, you plug it back in. Now here's where I would deviate a little bit from the scoring guidelines. So now we know that the natural log of W minus 300 is equal to 1 over 25t plus the natural log of 1100. They tend to clean it up a little bit more. Again, equal is equal. You don't get any points for being more fancy, okay? Your last job here is to get W by itself. So I noticed that there are two things in the way, the natural log and the minus 300. So take care of the natural log. We're going to have a base of E on both sides. So that'll cause you to have W minus 300 is equal to E to the everything in purple there. And then all you have to do is just add the 300 over. Pretty much W is equal to E to the blah plus the 300. Equal is equal, okay? You guys could totally capitalize on the amount of points here. Again, practice. If you know you're weak at slope fields and differential equations, get that packet back. I posted up all the FRQs in case you didn't get to take it home or misplaced it. But revisit it. Like, you guys could definitely do well on this AP exam with practice. So there you go. Thank you.